Hello guys, today we're going to go over 2.5, pretty much rational functions. Rational functions are functions that have a variable in the denominator. This is the parent function, 1 over x. Now, these functions look something like this. Maybe they have these strange curve-like behavior and they jump. Now, the first thing we're going to do is go over example 1. Finding the horizontal and vertical asymptotes of rational functions. Now note, there are also oblique asymptotes, horizontal asymptote, vertical asymptote, and obliques, but we're not going to focus on the obliques at this level. So if you look at this one here, this one has a horizontal asymptote. This one also has a vertical asymptote. Now, what is an asymptote? An asymptote is an invisible line in which the graph approaches that line but never actually touches it or crosses over that line. Basically, this value doesn't exist and the line gets infinitely close to it from both sides, gets closer and closer and closer, but never actually touches or crosses that line. Okay, it just jumps and it begins existing on this side. So how do you compare? How do you find the vertical asymptotes? The vertical asymptotes, I think this is the simplest way. All you have to do, let's look at a couple of examples. Let's go over a couple of examples. And again, the numerator can be any number, but when you're looking for vertical asymptotes, you only have to focus on the denominator. Let's take, for example, here. What value would make this denominator 0? The value that would make this denominator 0 would be the number 0. So at 0, there is a vertical asymptote at 0. What value would make this denominator 0? -1. So in this case, which is another rational equation, we would have our vertical asymptote at -1. Let's actually change this to make it a little bit more complicated. 4 or 5 multiplied. So if you take this example, the trinomial, when you factor this, you would end up with x plus 5, x plus 1. When you multiply these two, you get 5. When you add these two, you get 6. And now you ask yourselves, what numbers would make this denominator 0? It will be -5 and -1. So this function would have two asymptotes, two vertical asymptotes at -5 and also at -1. So to sum it up, to find vertical asymptotes, you only care about your denominator. And you ask yourself, what values would make this denominator 0? You would end up with 1 over 0, 1 divided by 0, which is not a number, doesn't exist, and that's where you would have your asymptotes, at the values that make your division not exist, pretty much. That's it for vertical asymptotes. Now, and again, remember, you don't care what's in the numerator. You don't care about the numerator. It could be anything. Doesn't matter. Focus on the denominator. The values that make your denominator 0 are the values where we will have vertical asymptotes. Now, in order to have horizontal asymptotes, there could be 3 outcomes. Either the equation does not have a horizontal asymptote, it has a horizontal asymptote at 0, meaning right here on top of the x-axis, or it has a horizontal axis at some other place. How do you figure out where it's at? Now you do have to focus on the numerator. But all you have to focus on the numerator and denominator, but all you really care is the leading term. I don't know, let's make this 7x8. Actually, let's make this 3x8. Let's look at this example. And again, all you have to do is compare the leading term in the numerator being 6x to the 4th and the leading term in the denominator, 3x to the 8. Let's just make it more complicated just in case. And again, just to emphasize, the The other numbers don't matter, just the leading term here and the leading term here. And you're gonna look at the degrees of those terms, the exponent, not the coefficient that's before them, just the exponents. And you're gonna ask yourself, which one's bigger? If the denominator is bigger, if the denominator's degree is bigger, again, coefficient, positive, negative, doesn't matter, doesn't matter. If your denominator's degree is bigger than your numerator's degree, the horizontal asymptote will always be at 0. If the denominator is bigger, the horizontal asymptote will be at 0. Now let's switch it up. Now let's say my numerator's degree is 7 and my denominator's degree is 5. When the numerator's degree is larger than the denominator's degree, there is no horizontal asymptote. There's just not. So the answer is no horizontal asymptote. Pretty simple. And now what happens when the degrees are identical? Now you start focusing on the coefficients. And all you have to do is divide the numerator's coefficient, which is 6, by the denominator's coefficient, which is 3. 6 divided by 3 equals 2. That answer will tell you where we have a horizontal asymptote when the degrees are identical. The horizontal asymptote will be at 2. So again, let's go over the three cases. x2, when the denominator is bigger, the horizontal asymptote will be 0. When the numerator is bigger, there is no horizontal asymptote. And when it's the same, you divide, and the number that you get will tell you where the horizontal asymptote is at. That's pretty much it for example 1. The next thing we're gonna go over, again, as far as graphing goes, you can use the graphing calculator. I don't expect you to know these graphs like the other parent functions. Just don't worry so much about the rationals. They are difficult to visualize in your mind, so just graph them using the graphing calculator. The other part is, let's go over example 6, which is solving simple rational equations. Again, let's say I have this case right here. 6 over x minus 8 equals 0. Now the trick of these rational equations is quite simple. All you have to do is get rid of your denominators. That's it. So how do I get rid of this denominator? Multiplying this term by x minus 8. But how do I multiply this term by x minus 8? I have to multiply this side by x minus 8 and this side by x minus 8. So I would end up with x minus 8 plus 6 x minus 8 times x minus 8 equals 0, x minus 8. Notice I multiplied x. Again, this is an equality. You can add whatever you want to both sides. You can divide, you can multiply. So here I multiplied by this term, both sides, to get rid of the denominator. So what's going to happen here is I'm actually going to get rid of that, and I'll be left with this plus this equals 0 because this cancels out. X times x is x squared. X times negative 8 is negative 8x plus 6 equals 0. And now, in order to solve, all you have to do is know all the ways we've been looking, okay? Graph, quadratic formula, factoring, solve. You have multiple ways how to solve it. So again, if you have multiple denominators, and we're gonna go into this a little bit later, another day, but if you have multiple denominators, then you just multiply everything times both denominators just to get rid of them. It's gonna give you quite a larger equation, but again, you're going to get rid of the denominators. So all you have to do is multiply everything by the denominators to cancel them out. And you'll be left with a normal, non-rational equation that you just solve as normal. Have a great day. I'll see you soon. That's it for today.